So this is again a very short RC, not very short. I would say it's an average size because most of the RC passages in CAT would be slightly 40% more in length than the one that you see here. Now the good thing about short RCs is that the questions are a little difficult. They're not as straightforward. And secondly, short RCs to begin with, when you start with short RCs, you have a narrow focus range. So before you move on to the lengthier RCs with 7-8 questions, I would suggest that you start with the short RCs. That way you will develop gradually the habit and the ability to focus on longer stuff by first focusing on the smaller stuff, right? So let's read this passage. It says, most attempts by physicists to send particles faster than speed of light involve a remarkable phenomenon called quantum tunneling, in which particles travel through solid barriers that appear to be impenetrable. If you throw a ball at a wall, you expect it to bounce back, not to pass straight through it. Yet subatomic particles perform the equivalent feat. Quantum theory says that there is a distinct, albeit small, probability that such a particle will tunnel its way, right? Will tunnel its way. Wait, something is missing, I think. No, it's fine. Yet subatomic particles perform the equivalent feat. Quantum theory says that there is a distinct, albeit small, probability that such a particle will tunnel its way through a barrier. The probability declines exponentially as the thickness of the barrier increases. Though the extreme rapidity of quantum tunneling was noted as early as 1932, not until 1955 was it hypothesized by W and E that tunneling particles sometimes travel faster than light. Their grounds were calculations that suggested that the time it takes a particle to tunnel through a barrier increases with the thickness of the barrier until tunneling time reaches its maximum. Beyond that maximum, tunneling time stays the same regardless of the barrier thickness. This would imply that once maximum tunneling time is reached, tunneling speed will increase without limit as barrier thickness increases. Several recent experiments have supported this hypothesis that tunneling particles sometimes reach superluminal speed. According to measurements performed by Raymond, Chiao and colleagues, for example, photons can pass through an optical fiber at 1.7 times the speed of light. Now, if you go through this passage and if you remember what you have done, you'll realize that it's a technical passage. It's not something that you come across daily in your normal reading. So it's highly probable that even after one reading, you may not understand a single thing in the passage. It's very difficult. And going back to it and reading again would mean giving more time to it, right? So what we learn from it is that sometimes even short passages can give you trouble. Passages which are very, very technical are more likely to give you trouble. And that's the reason why sometimes when we are not familiar with the technicality of the subject being discussed, we have difficulty understanding it. But my suggestion is that whenever you have such a technical topic, you try to basically map the passage. Now, how would I map this passage? I know that the author speaks about quantum tunneling, and it is something about the speed of light. And then the word Wigner and Eisenband has come. And there is some technicality about the barrier thickness and the speed at which something happens. So I know that lots of things have come, but instead of reading the passage again to get a better grip on it, I would just have a look at the questions. It's quite possible that the questions may be about specific things to which I can go and find and mark the answers. There is no need for me to read the whole passage again. For example, it says here that the author of the passage mentions calculations about tunneling time and barrier thickness. So you know that the calculation stuff has come somewhere in the passage. So you have to go and check where the calculation has come. And the calculations have come not at the start, but somewhere in between where it says here that their grounds were calculations, correct? So I have to just read this part of the passage to mark the answer. There is no need for me to read the above part above it and the part below it. So let's go and see what exactly it says. It says, though the extreme rapidity of quantum tunneling. So it says, though the extreme rapidity of quantum tunneling was noted as early as 1932. Not until 55 was it hypothesized by Wigner and Eisenberg that tunneling particles sometimes travel. So the idea of tunneling was known to people, but the idea that tunneling particles travel faster than light was only after Wigner and Eisenberg. Their calculations, their grounds were calculations that suggested that the time it takes a particle to tunnel through a barrier increases with the thickness of the barrier until tunneling time reaches its maximum. So the calculation stuff has been discussed as though the author wants to illustrate or support Wigner and Eisenberg's hypothesis, right? So if you go and check, you have to mark something which is approximating with that, right? And it says suggests that tunneling time is it is not unrelated. It is in fact related. So A goes out. Explain the evidence by which Winger and Eisenberg discovered the phenomenon of tunneling. So it's quite possible. It's quite possible that their calculations were the evidence by which they discovered. But then the problem is, did they discover? Because you might mark the choice, but understand these people. It says that though the extreme rapidity of quantum tunneling was noted as early as 1932. So in 1932 it was known, but only in 55 was it hypothesized by these two people that it travels faster than light. So we know that what these two people did. They hypothesized that it travels faster than light. The credit they should get is for the idea that they travel faster than light. But the discovery credit should not go to them because the passage is not mentioning that. So we can definitely put B in question. Why? Because of the word discovered. Described data is challenged. Nothing has been challenged by Raymond and his colleagues. So this also goes out. So we know that the answer is from D or E. Question why particles engaged in quantum tunneling rarely achieve extremely high speed. He's not again the problem. He's explaining the basis for Winger and Eisenberg's hypothesis. What is the basis? The basis is calculation. When they calculated, they realized that it can travel faster than light. So can we say that E explains precisely what A asks? The author of the passage mentions calculations. Why? Because on the basis of this calculation, Winger and Eisenberg hypothesized that the tunneling speed could be faster than light. So E is the best choice, and the second best choice would have been B. But the B has a flaw in it. It speaks about discovery, which is not implied in the passage anywhere. So we can say that option E is the best choice and the right answer definitely, and we can move ahead. So what we have done, we have checked everything. We have checked the options which are totally unrelated, so we have ruled them out straight away. And when we found an option somewhat related to, we checked it, we read the whole option, and then we realized there are certain words which are not matching. Let's go and take the second question. It says here that the passage implies that if tunneling time reached no maximum with barrier thickness. So the author says if tunneling time reached no barrier thickness, no maximum. So it says here, that is what it says, if tunneling time reached no maximum, then what would happen? So tunneling time is Tt, right? And barrier thickness is Bt. And the author says that when tunneling time reaches maximum, then something happens, right? So he has discussed that again in the same part of the passage where we found the answer for the first question. It says here that time it takes a particle to tunnel through a barrier increases with the thickness of the barrier until Tt reaches a maximum. Beyond that maximum, beyond that maximum, tunneling time stays the same regardless of the barrier thickness. So it will reach a maximum tunneling time and it will remain the same regardless of how much you increase the barrier thickness. Correct? This is what it means. So once you reach T max, so once Tt reaches max, it remains the same. Correct? Regardless of how much the barrier thickness increases. You can keep on increasing it, no problem, but this is going to be at the same level because it has reached its max. Now the author says this would imply that once maximum tunneling time is reached, tunneling speed will increase without limit. So the author says tunneling speed will increase without limit. So once you reach Tt max, Ts will increase without limit. So the idea is once you reach TT max, correct, the TS will increase without limit. So if you don't reach TT max, what will happen? This is what the question says. The question says if you don't reach TT max, TS will not increase without limit. This is what the question is all about. So TT max, once it reaches, it remains the same regardless of the barrier thickness. So I am putting it BT. BT increases indefinitely, no problem. Once TT max is there, it will remain the same no matter how much you increase the barrier thickness. And once you reach TT max, the tunneling speed will increase without limit. But if you don't reach TT max, then the TS will not increase without limit. So if you go and have a look at the question says the same thing. The question says if tunneling time is reached no maximum, then what will happen? The TS would not be expected to increase without limit. So this is the answer straight away. The point is, some of you might mark ABC. It says TS would increase with barrier thickness. See people, once TT reaches maximum, it remains the same regardless of barrier thickness. Correct? But tunneling speed would increase with barrier thickness. It is TT that is increasing with barrier thickness. The relationship in the passage that the author discusses is with respect to TT and barrier thickness. He says that the tunneling time will increase depending on the barrier thickness. And once the TT has achieved its max, it will not increase without limit. I mean, it will remain the same. So what we are discussing is two relationships. One is the tunneling time vis-a-vis barrier thickness, and the other is tunneling time with respect to speed. So we have in the passage relation between tunneling time and speed. And none of these options are focusing on that. They are focusing on barrier thickness. But barrier thickness has been related to in the passage with tunneling time. That's the reason why I have put TT max, BT, BT all the while. So barrier thickness are not connected with TS, TS or TS. They are connected with TT. And TS is connected with tunneling time. How? The author has said clearly here that beyond the maximum tunneling time stays the same regardless of barrier thickness. This would imply that once maximum tunneling time is reached, tunneling speed. So tunneling speed has come here. And in the earlier part, you have barrier thickness and tunneling time. So TT has been related to TS, TT has been related to BT. There is no relation between TS and TT. TS and BT, that is speed and barrier thickness. So D is the best choice. You just reverse of what the author implies. So the author says that if tunneling time reaches the maximum, tunneling speed would increase without limit. That means if tunneling time does not reach maximum or there is no maximum in it, the tunneling speed would not increase without limit. So straight away D becomes a choice. Let's go ahead and take the next question. Which of the following statements about the earliest scientific investigators of quantum tunneling can be inferred from the passage? So the author says which of the following statements can be inferred about the earliest scientific investigators on quantum tunneling. So when you look at the earliest, you will have to go and check where exactly that thing has come in the passage. The word earliest has come, and earliest means we have to focus on date. So the author has mentioned the dates somewhere at the start. He says that though the extreme rapidity of quantum tunneling was noted as early as 32, so quantum tunneling and the speed was noted in 32, not until 55. So 32 is basically the earliest part. We cannot go before that. Why? Because the passage nowhere implies from 32 you come to 55, and from 55 you come to recent experiments. So after 32 it is moving in the forward direction, not in the backward direction. So whatever is applicable to 32 is applicable to the question. So what does the question say? That which of the following statements about the earliest scientific investigators of quantum tunneling can be inferred? So what can be inferred from the passage? They found it difficult to increase barrier thickness continually, but did they put in efforts to increase barrier thickness? They anticipated later results of Xiao. Again, there is no connection established in the passage between B, that is Xiao and his colleagues, with the 32 scientists. What we get to know here is that they did not suppose tunneling particles could travel faster than light. This is definitely true. Why? Because if you read, you will realize that they knew about quantum tunneling and its rapidity as early as 32. But not until 55 was it hypothesized that tunneling particles sometimes travel faster than light. So those people in 32 knew that it is traveling at a very high speed, but only in 55 it became clear that it could travel faster than light. That means in 32 these people would not have thought that the tunneling particles could travel faster than light. This is what we can infer, because if this thing was became known to people in 55, that means before 55 it was not known, and that means the earliest investigators did not suppose that tunneling particles could travel faster than light. So C is the choice. A good passage. See, it's a very, very short passage, but most of the questions that have come in the from the passage, they are not based on overall understanding of the passage. They have come from specific areas of the passage. So sometimes when you read the passage, it's quite possible that you won't understand anything about what exactly is happening, because there is so much of technicality that is difficult for you to put it in very simple words. You're not a physicist, you're not someone who has done quantum tunneling, so you'll not be able to understand what exactly is going on. So what should you do? Leave the passage? In that case, you read the passage, check what has come where. For example, the word Eisenberg had come in between, the word 32 had come somewhere in between, then the word 1955 had come, then the word calculations had come, the word optical fiber and photon had come towards the end, the word Raymond Chow had come towards the end. So if there is a question on Raymond Chow, I will go there and check what exactly he has to say, and I will use the options to mark the answer. So what we learn from this passage is that many a time you will not understand the technicality of the passage. So there is no need to panic. You have to go, read the questions, check the ones that can be solved, and try to mark the answer by going to that part of the passage from where the question has come. Use the options smartly and you will definitely get the answer.